Well, it's noon. I don't have anybody in here yet, but I will go ahead and start going through some of the questions from the homework assignments. If you didn't notice in the last video, that's what I typically do during this time is I will do you guys' homework assignments and try all the different problems, make sure we're all getting the same answers, and offer the ability for anybody who wishes to comment upon them and ask any questions they want. Always welcome to join in no matter what or how long you need to be in here, and then leave whenever you're done. But otherwise, let's go ahead and take a look. Let's see, right there, boom. Okay, oh my God, that's really zoomed in. I have to not do that. Okay, better. All right. So let's see, I'm gonna put up the first homework assignment. I'm gonna start with the college algebra assignments. Let's see, we had one from Monday, one from Tuesday, and one from Thursday. So let me pull those out. Let's see, there we go. All right, from Monday, this would be college algebra, day 4's homework assignment. All right, let's take a look. All right, we had 25 through 40, and it stated the following exercises, simplify the given expression, write answers with a positive exponent. Let's go ahead and get started. 25. All right. We got a person joining. Yay. Hey, Miranda. All right, so original problem was a cubed, a squared over a. So let's see. For this one, we'd have the top, which would be a to the 5th over a. This would use our additive property, which states that if you multiply two variables with the same base, you'd add their powers. So 3 plus 2 is 5. Then we use our quotient property, which states we divide, we end up subtracting. So you get a fourth. 26. Hi, Miranda. I can't hear you if you're talking, but that's okay. I'm just working on some college algebra problems. All right, 26. We have m n squared over m to the negative second. Okay, so I have an m on top and m on bottom. I can use the quotient property, which lets me know to subtract those. Now, this would become a positive 1 minus a negative 2, giving me a double negative, giving me m cubed n squared. There's just no terms to put the n with, so it just stays n. Notice that we are finished when two things happen. There are no negative powers and no powers of 0. 27. We got b cubed c to the 4th squared. For here, we use our property, which says that we would multiply to the powers. This becomes b to the 6th, c to the 8th, and there's nothing else to do, so that's our answer. 28. 28, we got x to negative 3 over y squared. It's a negative 5th. For these kinds of problems, do note that anytime you're looking at these kinds of problems, I did this one in class, but you can choose to do it multiple ways. You can choose to simplify the negative 3 inside first. You could choose to distribute the negative 5, or you could choose to simplify the negative 5. It all depends on what you want to do. So I want to distribute. Give me x to the 15th over y to the negative 10th. And the negative powers, remember, always flip. So if it was on bottom, it is now going to go to the top and become positive. X to the 15th, y to the 10th. That's 29. So now we got ab squared divided by d to the negative 3rd. This I'm going to rewrite first. ab squared divided by d to the negative 3rd. And from here, I'm going to simplify that negative 3rd power. Negative powers on bottom will go to the top. This becomes a b squared d to the third. They're all positive, none of that is zeros. That's our solution. 30. Let's see, we got, I think this is another one we did in class. So w to the 0 power, x to the 5th power, negative 1st power. Again, I'm going to choose to distribute first. 0 times negative 1 would be 0. 5 times negative 1 would be negative 5. Remember, we multiplied to the powers, not to the numbers. So negative 1 times 0 is 0. Negative 1 times 5 is negative 5. Negative powers drop to the bottom, which gives me w to the 0 over x to the 5th. Remember, powers of 0 become a 1. So it's a 1 over x to the 5th. In this case, my w disappeared because of the power of 0. Theory 1. M to the 4th over n to the 0. N to the 4th doesn't do anything, but n to the 0 power, anything to the 0 power is always 1. And when you divide by 1, nothing happens, so this becomes just m to the 4th. We got 32. Let's see, we got y to the negative 4th, parentheses, y squared squared. Okay, now according to order of operations, I have to do the powers first. So anything in the parentheses should be simplified first, but there's nothing in the parentheses that simplifies, it's just y squared. So then I need to do the outside power second, because remember, this is being multiplied to each other. And multiplication comes after exponents. So this will become y to the negative 4th times y2 squared would become y to the 4th. Because they're being multiplied, we add the powers. Negative 4 plus positive 4 is 0, and anything with the 0 power is 1. There we go. Back over here. Oops, apologize, I lost the page. So we got our first 8 problems in that homework assignment, 25 through 32. Okay, let's now start on 26. Sorry, 33. All right, 33. This is where we start getting to some fun ones. P to negative 4th, q squared over p squared, q to the negative 3rd. Okay, so I'm going to simplify the division part first, which I'm allowed to do. I can do it in any order I choose, as long as I do both pieces eventually. So I'm going to take the top minus the bottom, so that would be p. Negative 4 minus 2 would be negative 6. On the other one, for our q, we have 2 on top and negative 3 on bottom. 2 minus a negative 3 will be a positive 5. Double negative makes it plus. And then I'm not allowed to have negative powers. So remember, negative powers simply drop to the bottom and become positive. And there's 33. On 34. This one tripped me up the first time I saw it, because for some reason I wasn't thinking. I thought the x was another variable, but it's not. And so I'm going to rewrite this first. This is just LW squared. Remember, when you have two things being multiplied, you have to distribute the 2 to both pieces. This becomes L squared W squared. Okay. All right. 35. I got y to the 7th to the 3rd divided by x to the 14th. Just like before, when I have the operations like not written the way I want them written, I'm going to rewrite first. This becomes y to the 7th to the 3rd divided by x to the 14th. The 14th is a positive, so I'm not going to do anything to it. But on top, this will become y to the 21st. Remember, powers of powers multiply, so we end up with this. And no, I can't simplify these two because they're different bases. Remember, I can only simplify same base. So this one is a base of a y, this is a base of an x. I cannot like put these two together and get a 7 or something. That doesn't work. Let's go to 34. No, why are we doing 34? 36. A over 2 cubed quantity squared. So just like before, when I have a parentheses, I have to distribute to every term. So this becomes a squared over the 2 multiplies. So this becomes 2 to the 6th. Note that with these rules, the base shouldn't change unless it's to a 0 power. So anytime we talk about these functions, if it's an a, it should stay an a. If it's a 2, it's going to stay a 2 until we accept that it's going to be different. So this is actually an acceptable answer. However, you can use either some mental math or a calculator if you wish, and actually do 2 to the 6th. 2 to the 6th is 64. And that is also an acceptable answer. My big goal is to make sure you're doing the rules correctly, not to, get you gotcha for not simplifying or oversimplifying. 37. We have 5 squared m divided by 5 to the 0 m. This was one of the more missed questions from those that have turned it in. So let's take a look. I'm going to write it first correctly. 5 squared m over 5 to the 0 m. We then subtract the powers. So this becomes 5 squared because 2 minus 0 is 0. And this becomes m to the 0 power. Because remember, there's a 1 on top and a 1 on bottom. So one of our properties is the identity property. And then we subtract 1 minus 1 is 0. Now, 5 squared, we can leave as 5 squared, or we can simplify it to 25, but we must simplify the m to the 0 power as a 1, giving us either 5 squared as one acceptable answer, or 25 as the other acceptable answer. Look at 38. We have 16 square root of x quantity squared all over y to the negative first power. Okay, let's simplify the exponent first. There's nothing in the parentheses to simplify. 16 times the square root of x, just 16 square root of x. When I simplify this power on the outside, I have to distribute, so this becomes 16 squared and square root of x squared. At this point, I'm going to go ahead and take an algebraic step here. 16 squared, I'm going to leave. Squares and square roots always cancel, leaving just an x over y to the negative first. And now, since I've taken care of everything on the top that I care about, I'm going to simplify the bottom. This becomes 16 squared x y. It should be y to the first, because remember, it'll go to the top and become positive, but y to the first is just y, so these two are the exact same thing. 39. For 39, we have 2 cubed over 3a negative second power. For this one, I'm actually going to use a trick that you can use. You can simplify the negative power first. So I'm going to do that. Negative powers will come to the top and become positive. This becomes 2 to the third 3a squared. So negative powers take the entire thing that has a negative power and move it to the top and becomes positive. It always flip-flops. So if it's on bottom, it goes to top. If it's on top, it will go to the bottom. But it's everything with that negative power goes to the top, or everything with that negative power goes to the bottom. And here I can distribute, becoming 2 cubed times 3 squared a squared. This is one acceptable answer. However, 2 cubed is 8, 3 squared is 9, 8 times 9 is 72, a squared is the other acceptable answer. And then 40. On 40 we have, this is I believe the last one we did, m a to the 6th squared times 1 over m cubed a squared. Let's see. When we simplify this, we end up with, I'm going to simplify the top first. It becomes m squared a to the 12th times 1 over m cubed a squared. Now, remember, this is actually all over 1. And then we can just multiply top times top and bottom times bottom. Give me m squared a to the 12th over m cubed a squared. Now, 2 over 3 is subtraction, so we do 2 minus 2, it becomes m to the negative first power. 12 on top, 2 on bottom, we subtract those, it becomes a to the 10th. This is not acceptable, we are not allowed to have negative powers. This becomes a to the 10th on top, m to the first on bottom, which is just m according to the identity rule. There's the first homework assignment. Even talking through it, it still took less than 15 minutes. So let's take a look at second homework assignment. So we had a homework assignment last night. That homework assignment was this one. It's got to do with the scientific notation. So we had 21 through 24 and A through E. All right, 21. Our original number is 0.1234314. 22. Our number is 148, 000, 000. 23 was 1.6 times 10 to the 10th. 24 was 9.8 times 10 to the negative 9th. Okay, let's do this. Top one. So to get our solution, we have to count how many places it is from our current decimal place to our new decimal place. So my new decimal place needs to go at the first number that is between 1 and 10, not including 1. So 1, 2, 3, 4, 5. This would be 3.14 times 10. Now, since we are going to the right, this would make this a negative 5. Small values get negative exponents. For 22, same thing. Our new decimal point needs to go right here between the 1 and the 4. So I count 1, 2, 3, 4, 5, 6, 7, 8. So 1.48 times 10 to the 8th. It's a big number, so it gives a positive value. All right, next we have 1.6. So I need to move the decimal place 10 places. In this case, since it's a positive 10, it's going to be a big number, so I'm going to move it to the right. So this becomes a 6, so 1.6. I use grid paper for this, so I can easily get track of my zeros. So this is 1, 2, 3, 4, 5, 6, 7, 8. And so we end up with this number, 160,000 as well. Nope, 160 million. Ooh, big number. So you always keep track of where the old one was versus where the new one is. In this case, I have 9.8. I see it's a negative, so I'm going to move to the left to give myself some space to work with. 9.8. And I'm going to have 8 spaces, sorry, 9 spaces to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal place. So I end up with 0. A bunch of zeros, 98. There we got it. Let's look at A, B, C, and D. We have negative 7.5 times 10 to the 8th times 1.13 times 10 to the negative second. For B, we had 1.24 times 10 to the 11th divided by 1.55 times 10 to the 18th. For C, I have 3.72 times 10 to the 9th times 8 times 10 to the 3rd. D, I have 9.933 times 10 to the 23rd. Yeah, 10 to the 23rd. Divided by negative 2.31 times 10 to the 17th. And for E, negative 6.04 times 10 to the 9th times 7.3 times 10 to the 2nd times negative 2.81 times 10 squared. Okay, let's do it one at a time. So remember, to do these problems, you can, whatever operation is between them, you can switch the orders of them in order to do the operation. So for mine, I'm going to take negative 7.5 times 1.13, and then afterwards do the 10 to the 8th and the 10 to the negative 2nd. So I'm going to take negative 7.5 times 1.13, and then I'm going to take 10 to the 8th times 10 to the negative 2nd. So there's my rewrite. And then multiply. Calculator is handy here. Pull mine up. All right. Negative 7.5 times 1.13 is 8.475. 10 to the 8th times 10 to the negative 2nd, we would add those powers together because they're being multiplied. 10 to the 8th times 10 to the negative 2nd would be 10 to the 6th. My number is between 1 and 10, so I stop, and that's my solution. For the next one, again, I can do roughly the same process, but because there's division, it's helpful to rewrite it this way first. 1.24 times 10 to the 11th over 1.55 times 10 to the 18th. And then I will simply do the first column's division separately from the second column's division. So 1.24 divided by 1.55, let's do that math. 1.24 divided by 1.55, end up with 0.8. 10 to the 11th times, or divided by 10 to the 18th, we would do subtraction. 11 minus 18 would become negative 7. This is not quite right though, because this number is not between 1 and 10. I have to move this one decimal place to the right. Now moving it one decimal place to the right would cause this number to shift. If you don't remember how to shift them, you can always sit down and be like, hey, I have 0.8 and then negative 7 would mean I move it to the left. So 1, 2, 3, 4, 5, 6, 7, at a decimal place. And then you can redo your count. If you redo your count, it should be 8 times 10 to the negative 8th. If you don't remember how to do it by here, always works. From here, let's take our next step. So again, we do our numbers, our standard values separately from our powers. So 10 to the 9th times 10 to the 3rd. We use our rules to simplify the powers. We use just basic algebra to simplify the numbers. 3.72 times 8 is 29.76. 10 to the 9th times 10 to the 3rd would be 10 to the 12th. Multiplication means addition, so 9 plus 3 is 12. And I move this one place to the left. Again, if you don't remember how to do it, or if you just don't want to learn how to do it that way, you can always just rewrite this number 2, 9, 7, 6. And then this place is 12 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. And then take that number and write it in scientific notation. So the decimal point will need to go here, which means we have 2.976 times 10 to the 13th. D. Same basic form. So we do the rewrite first. 9.933 times 10 to the 27th over negative 2.31 times 10 to the 13th. Is that 13? My handwriting's terrible today. That's 17. Good thing I checked. That's a 23. Hit those backwards. 23 and 17. Boom. Okay, so we can do the first column separately from the second column. So handy dandy calculator. 9.933 divided by negative 2.31. Well, that's a nice number. So we end up with negative 4.3. And then division becomes subtraction. So 23 minus 17 will become a 6. This number is between 1 and 10, and so it's good. All right, our last one. We can do our numbers separate from our other pieces. So negative 6.04 times 7.3 times negative 2.81 times 10 to the 9th times 10 squared times 10 squared. Double check. Yep, looks good. Okay, let's multiply the numbers in front first. So negative 6.04 times 7.3 times negative 2.81. We end up with 123.89852. Fancy. Times 10 to the 9th, 10 to the 2nd, 10 to the 2nd. Add the numbers together. 9, 2, and 2 would make a total of 13. So you have 123.89852 times 10 to the 13th. This is not in the correct form. The first number is not between 1 and 10. I need to move my decimal place 2 more places to the left. I'm going to shorthand that a little bit. I already know it should be 1.2389852 times 10 to the 15th power. You can find it the same way we found these two. All right, homework assignment number 2. Even going step by step explaining. It's less than 15 minutes. Today's homework assignment. Ooh, yeah, my favorite. I love radicals. They're the best. Okay. Okay, we got the square root of 256. We got the double square root of 256. We got the square root of 4, 9 plus 16. Square root of 289 minus square root of 121. 9 square root of 196. 10, easy one. Square root of 1, 11. Square root of 98. Wonder where I got that number from in our assignment today. 12. Square root of 27 over 64. 13. Square root of 81 over 5. 14. Square root of 800. 15 square root of 169 plus square root of 144. All right, this first list, I'm going to go pretty quick through them. That is because, well, if you memorize your table of squares, these do go really quick. So let's start at the top. Oh, this is college algebra, day 7. All right. First one, the square root of 256 is 16. If the square root of 256 is 16, then the double square root would just be a square root of 16, which is 4. All right. 9 plus 16 is 25, so we end up with 4 times 25. 4 times 25 is 100, and the square root of 100 is 10. Going really fast. All right. Square root of 289 is 13. Square root of 121 is 11. Notice I'm doing the square root part of the operation first because the square roots have a subtraction sign outside. Up here, I had to do the inside piece first because they're inside of the radical. 11 minus 13 is, of course, 2. Square root of 196 should be 14. I always have to check that one. Square root of 1 is, of course, 1. Square root of 98 we did in class, but it is actually 2 times 49, which is 7 radical 2. For 12, we have square root of 27 on top, square root of 64 on bottom. On top, we get square root of 9 times the square root of 3. On bottom, 64 is a square root, so we can just leave that. Square root of 9 is 3, so on top we get 3 radical 3. On bottom, we get 8. Remember, I'm going quick through it, so 9 times 3 gets us back to the 27, so we know this is allowed. And the square root of 9 is, of course, 3. Square root of 3 is just a number, and so we can leave it as the square root of 3. Square root of 64, remember, we can always split with division or multiplication. So on top, we split according to multiplication. 9 times 3 is 27 when multiplied, so we can split it into 9 and 3 respectively. 64 can be split using division, and the square root of 64 is just a number, so there's no more work to do. On 13 is the first time we get our real kicker problem. Square root of 81 on top, divided by the square root of 5 on bottom. Square root of 81 is, of course, 9, but square root of 5 is just the square root of 5. I'm not allowed to have a radical in the denominator, so I multiply by the radical in the denominator in order to get rid of it. On top, we end up with 9 square root of 5. On bottom, we end up with just 5 by itself. 14. 800 is pretty big. I'm guessing it's not very nice. So I'm going to break this down. Got it. It's 2 times 400. Square root of 400 is 20. So square root of 2 times 20, which is 20 square root of 2. On 15, the square root of 169 is 13. Square root of 144 is 12. 13 plus 12 is 25. I cannot put these together until I simplify them. When I simplify it, I can start to add and subtract them. Okay, let's look at the last 9. Let's see, starting with number 16. Number 16 has the square root of 8 over 50. 17 has 18 over the square root of 162. 18 has square root of 192. 19 is 14 square root of 6 minus 6 square root of 24. 20. 15 square root of 5 plus 7 square root of 45. 21. 21. Square root of 150. 22 is square root of 96 over 100. 23 is square root of 42 times square root of 30. 24. 12 square root of 3 minus 4 square root of 75. Okay, let's start with 16. Okay, I'm going to simplify first. Remember, you're allowed to simplify at any point in time. I'm going to take a 2 out of both the top and bottom, leaving me 4 over 25. The reason that's important is because it's going to make my process a lot easier later, because the square root of 4 is, of course, 2. The square root of 25 is, of course, 5. And notice how all my radicals have disappeared. So that must be good. Could I do what I did, like I did on number 12? Well, sure, I could have done that, but it's going to take longer. I should always look to see if I can find a faster way, and this is one of those. I can't do that on 17 because the top isn't in a radical, it's just an 18. So I have to simplify kind of the old-fashioned way. Now this becomes 18 over, now 162 breaks down into 81 and 2. So on top we get 18. The square root of 81 is 9, radical 2. I'm not allowed to run around with my radical down. So I multiply by just the radical portion. Notice I don't do the 9, just the radical 2. And this becomes 18 radical 2 over 9 times 2 is 18. Cool thing about that is the 18s and the 18 will cancel, leaving just radical 2. And if you type this into your calculator, these two do match, so we know we did everything right. All right. Okay, I'm back. Square root of 192. Let's see, I don't think that's a nice one. 96 is 14. So let's do it the old-fashioned way. So this becomes, I'm going to have to do a factor tree. So 192 breaks down to 96 and 2. 96 breaks down into 2 and 48. 48 breaks down into 4 and 12. And 12 breaks down, I'm running out of here. 4 and 3. All right, so 182 becomes this nasty square root. We got a 2, we got a 2, we got a 4, we got a 4, and we got a 3. So we got a pair of 2s, that means we have 2 squared. We got a pair of 4s, that means we have 4 squared. And we get a 3. Square and square root will cancel. Leave me 2 and 4, which is 8. Square root of 3. Ooh, that was fun. Okay, 19. So on 19, the best thing to do here is to simplify first. 14 square root of 6 is actually as simplified as it can be, but 6 square root of 24 is not. The 24 can be broken down into 4 and 6, because 4 times 6 is, of course, 24, which means that this becomes 14 square root of 6 minus 12 square root of 6. Now, we didn't talk about this today because I kind of just figured it was remembered, but you can actually factor this from before. We can take a square root of 6 out of both pieces, leaving me 14 minus 12. And 14 minus 12 is, of course, 2 with the square root of 6. So you can use factorization in a lot of different ways. So we can simplify this term just by factoring. I'll do the same thing on 20. This becomes 15 square root of 5. This becomes 7. Square root of 45 is actually the square root of 9 and the square root of 5, which means this becomes 15 square root of 5 plus the 9 becomes a 3, which makes this become 21 square root of 5. 15 and 21, I can factor out that square root of 5. And then I get 15 plus 21. 15 plus 21 is 36 square root of 5. Over here, I have 150. 150. I'm going to do a very neat little factor tree here. I know 25 goes into this. and I know 25 is a perfect square. If I could just figure out the other number that goes into it, I'm good. 25, 50, 7,500, 25. Okay, 6. So square root of 6 times the square root of 25. This becomes 5 square root of 6. Square root of 25 is 5. Square root of 6 is just the square root of 6. On this one, I'm going to break this into 2. Square root of 96 on top. Square root of 100 on bottom. Square root of 100 is, of course, 10. Square root of 96. The factor tree over here. 96. This is 2 and 48. 48 is 4 and 12. 12 is 4 and 3. This becomes 2, 4, 4, 3, which means I end up with 4 squared and 6 over 10. I mean, I get 4 square root of 6 over 10. I can also simplify that. Leave me 2 square root of 6 over 5, just simplifying a fraction. Okay. On 23, it's important to remember that you can kind of do this in the order you want. So I'm going to choose to simplify first and then put them together. So square root of 42, it doesn't simplify. So when I write it out its factored form, I'd have 2 times 3 times 7. Square root of 30 would be 3, 2, and 5. Now I can say I have 2 3s and 2 2s with a 7 and a 5 left over. I mean, I can write this as square root of 2 squared, 3 squared, and of course 35. That's 7 times 5. The square and square is going to cancel, leaving 2 times 3. Give me 6 square root of 35. It's a fun one. Neither one by themselves canceled, right? 2, 3, and 7, 2, 3, and 5. When you put them together, because they're being multiplied, you can put them together. That allows the double 2's to cancel and the double 3's to cancel, and leaving the 5 and the 7 behind to be remultiplied. All right. This one becomes 12 square root of 3 minus square root of 3 is as simplified as it gets. 4. Square root of 75 is square root of 25 times the square root of 3. Square root of 25 is 5, so this becomes 12 square root of 3 minus, we got 4 times 5 times 3, which is 20. Just like before, we can factor out that square root of 3, leaving 12 minus 20 behind. 12 minus 20 is negative 8 times the square root of 3, which is negative 8 square root of 3. There's all 3 homework assignments for college algebra done. Okay. Look at that. Now let's shoot the calculus. Today's assignment for calculus goes by super fast. The other two less fast. So let's go ahead and pull up. Got first homework assignment is just plugging stuff in. Ooh. Hey Miranda, you there?
Yeah.
Did you have any specific questions about the homework 4 or homework 6 or homework 7?
I'm working on homework 7 right now.
Okay.
I started it pretty late. I do have a question on one of these, or a few of these probably. Okay, on evaluating function notation, whichever one that is.
That should be homework 4. That's what I'm looking at right now.
Yeah. All right.
There's a couple fun ones in there.
Yeah. And
like
I
9, 10, and 11, and 12.
Yes, those ones especially. I full on didn't even know what to do, so I was just gonna wait until I could ask you.
Yeah, sure. Let's do them right now.
Because I had no clue. And then also, like, 4D, 5D, 6C and D. Yeah, that's it. I just had questions because some of them look like that was it. That's as simplified as you
We
can
got
get it. Then like I wasn't
4D,
sure.
5C and D, 6C and
No,
D.
4D, 5D, 6C and D. Now I could be wrong on some of them,
Okay, well,
but
let's start on real quick. We'll start with 4D, and then we'll do the last ones afterwards, okay?
okay.
So we have 4D says we want to do f of x plus delta x. And f of x tells us in the problem is the square root of x plus 5. You're going to hate me when I write the answer. You ready?
Because if it's like literally just that, then I'm gonna be pretty mad.
Everywhere there's an x, we replace it with x plus delta x.
Yeah. And then like I didn't because
And
you
then
can't.
this doesn't simplify at all. This is just x plus delta x plus 5.
That's it.
That's it.
Uh,
Because all
Great.
we've
All
done is
right.
we replaced x with x plus delta x. That's the definition.
That's what I was thinking. It could. That's the only thing because you can't. It's not a perfect square or anything. So like,
You're right.
what are you gonna do? So then.
Nothing.
All right. All right. My question on 5D is what's that like letter or whatever before the like -1? I can't read it. It's
It looks
too
like a T to
blurry.
me. I
Yeah, it's
apologize,
too blurry for me, and I can't read it. So
I'm going
I'm
to
not sure.
assume it's a T. Because
And
on the 6, it's also a T. And so
yeah,
we assume those are both T's.
that's the same thing for 6 too. Because
Yep.
it's just I can't read it, and I don't want to write down the wrong thing and then do the whole problem wrong. So,
I
and that's
apologize.
that's
That
the
should have been
same
clear.
thing for a lot of it. It's just I can't read what that letter is, and so I don't want to guess too much.
Yeah, of course. And so on 5D, we're going to assume that's a T. So we do 5 minus, everywhere there's an x, we're going to replace it with t minus 1 squared. And you know what the cool thing about calculus is?
Mhm.
Just circle that.
That's the wrong color. I almost messed up.
Don't hate yourself doing the stuff where you're like, let's make this weird. It doesn't need to be that bad, okay?
Yeah.
So 6c, we have x squared. My function is g of x, sorry. G of x is equal to x squared times x minus 4. And then for c, I'm supposed to do g of c. That just means everywhere with an x, we replace with c. So this would be c squared, c minus 4.
I got that, but I didn't know how to, if it simplified more than that. Okay, so that's it. All right, great.
And then d.
The second time.
It happens a lot in calculus that in many times you're actually punished in terms of the math work you're going to have to do if you simplify. Some, like, you have to simplify or bad things happen. But other times, if you get this answer, you're just like, circled, done, don't talk to me. Like example right here, I'm going to do t plus 4 squared times t plus 4 minus 4. I will simplify like one little bit. Like I have a plus 4 and a minus 4 right here, right? So those are going to cancel. And so I end up with t plus 4 squared times t. That's as far as I would simplify. Like there's no point in going any farther than that.
Okay, and that's t. And so I can just simplify that far. All right.
Let's look at 9,
Yeah.
10, 11, and 12. All right.
I had no clue, so I just didn't write anything down except for the start of 9, and then I'm like, what? And I just stopped.
If you just did the start of 9, you can stop. I don't need to simplify fully because simplifying fully takes a lot of extra algebra work.
No, I mean when I say at the start of 9, I mean I put f of x equals x cubed. That's it.
Nice. All right, so we got this function. And I will tell you, while this function looks weird now, you will use this a lot in chapter 2 of calculus. This is a very common function. It's referred to as the derivative function. And so let's explain kind of what this means. So we have first f of x plus delta x. That means I take the f function, and everywhere there's an x, I replace it with x plus delta x. I then subtract from that function the original function, f of x. I then divide that entire subtraction by delta x. So watch what this looks like. I take the original function, and everywhere there's an x, I plug in x plus delta x. So If the original function was x cubed, I replace it with x plus delta x cubed minus the original function is f of x, which we know as x cubed, and then delta x is just delta x. And so
Okay.
this is actually the function.
Gotcha. All right.
Now, this does actually simplify a lot, as it turns out. Like, this is part of chapter 2 of calculus, is learning how to take a function like this and simplify it down. I will just go ahead and tell you, if you fully simplified it, like if you got here, I'm not going to take any points off. If you
Okay.
fully simplified it, you should get 3x squared.
Gotcha. Okay. Well, I'm not too bad at simplifying. I'm not. Wow. Okay.
So here I can run through it really quick. The big thing is knowing how to cube this thing. Do you know your perfect cube formula?
Maybe.
For this one, it should be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. That should be x plus delta x cubed, is that statement. I use the perfect square or perfect cube formula to do it. In college algebra, you'll learn about something called Pascal's triangle. You can also use that to help you, which is really neat. There's just a lot of nifty little things you can do. We then have to subtract x cubed and put it all over delta x. Now, once I'm here, so I've taken that first piece and cubed it all out, minus the second piece, all over delta x. I have an x cubed and a negative x cubed. Those can cancel. That leaves me with 3x squared delta x plus 3x delta x squared plus delta x cubed all over delta x. What you can now do is you can factor a delta x out of everything on top, which looks a little something like this. Delta x comes out, leaving us with 3x squared plus 3x delta x plus delta x squared all over delta x. And then you can cancel those two, leaving us with the long answer, which is 3x squared plus 3x delta x plus delta x squared. But in calculus, you're only going to care about the first term. And so we usually only write the first term.
Gotcha.
But this is the fully simplified version. If you got at least this far, it shows me you know what you're talking about, because it shows me that you know how to plug into a formula. If you got into here, that means that you are like really advanced. You should be like top of class here or beyond.
Okay.
Like, you don't belong in high school anymore. Go away. All right. Let's do 10 real quick.
Okay.
10 is quite a bit easier because on 10, you have f of x minus f of 1 over x minus 1. Well, f of x is the original function, which we know as 3x minus 1, minus, and so f of 1 just means everywhere there used to be an x, you need to plug in a 1, so 3 times 1 minus 1. And then x minus 1 is just x minus 1. Let's simplify some stuff here. 3x minus 1 is 3x minus 1 minus 3 times 1 is 3 minus 1 is 2, so we minus a 2 over x minus 1. We can then combine like terms with the negative 1 and the negative 2, so we get 3x minus 3 over x minus 1. From there, you can factor a 3 out of everything on top. So 3 x minus 1 over x minus 1. And the x minus 1's cancel, leaving just 3. And so the answer on number 10 is just 3. Now on 10, like you can go that far very simply as long as you are faithful with your algebra. 11 is a very similar problem, but you should stop earlier. On number 11, if you stopped right here, like just plugging everything in, I'd give you a smiley face and say, good job.
Okay.
So like 11, we have f of x minus f of 2 over x minus 2. Okay, so this becomes f of x is 1 over the square root of x minus 1 minus f of 2, so that'd be 1 over square root of 2 minus 1 all over x minus 2. Like if you just looked at that and was like, I don't think I can do much more, I'd be like, oh, come on. You can at least simplify this thing. But even then, like I'd stop right after that. So this would be 1 over the square root of x minus 1 minus square root of 2 minus 1 would be square root of 1. 1 divided by 1 is 1. So we'd end up with that over x minus 2. And I'd be like, circle that, you're done. There's no need to go any farther than that. And so your big thing is being able to take that first step and simplify what you can. If you get to a point where you're like, I'm not sure I can simplify anymore, then just stop. I'd rather you stopped than kept going and get it wrong.
Yeah.
Because I can teach you how to go farther, how to go faster, but I can't teach you if you're screwing it up all the time. You know what I mean?
Yeah.
Okay. Any from like the second assignment or the third?
Are we not doing 12?
12? Yeah, actually 12. Sure.
I was just wondering because you stopped there.
So our original function is f of x, and we have x. Is that a cube?
Yeah, I think so. It looks like one.
It looks like a cube. My screen is even worse than your screen, I'll bet. So my screen is the scanned copy from the book. And we're trying to do f of x minus f of 1 over x minus 1, so the same function. Okay, so we have the original function, x cubed minus x minus f of 1, which means everywhere there used to be an x, I replace with a 1, all over x minus 1. If you got this far and circled it, I'd criticize you. I'd be like, hey, you know you can go farther. There's stuff you can simplify. Like 1 cubed is 1 minus 1. 1 minus 1 is 0. So we end up with x cubed minus x minus 0, but the minus 0 doesn't do anything, all over x minus 1. If you stopped there, I would be okay. But this can be simplified farther. For example, you could factor an x at the top. And then the top actually can be factored again. So x squared minus 1.
X minus 1, x plus 1. Right?
Very good.
Yeah.
And then if you do factor it that far, you can see that, you know, the x minus 1 on top and the x minus 1 are going to cancel. You know, with x plus 1. And so if you stopped here, like I'm not going to complain. You did everything right.
Yeah.
But if you got here, I'd be like, you're ready. You're golden for calculus.
Yeah, 12 was pretty easy. It's probably one of the easier ones.
10 and 12 were both easier, in my opinion.
Yeah.
11, just because it's nasty, it's rough. And 9, because it's a different function, it's rough. But 9 ends up being the one you use a lot more often, ironically. So.
Okay. I think that's all my questions on that one. I don't know if I got all of them right, but that's all the questions I have on that assignment.
Okay.
And then
I'll try to post solutions for all of these. I'll probably have to do it tomorrow, but that'll be like in the morning, so you can check them before you turn them in.
I think
I'll try to get them done tonight if I can.
The calculus day 6 one, the domain and range, I was pretty confident on. Might not have gotten it all right, but I didn't have any questions, and then I'm working on day 7 right now.
Okay. Just out of curiosity, for the domain and range ones, did you use the graph or did you use the equation?
I used the equation and I used the graph just to double check myself, but mostly, yeah.
That's smart. That's
because
smart.
I wanted to make sure, but I did the equation.
Perfect. All right.
Yeah.
Well, if you have any questions, shoot me a message, okay? I don't mind. I'm going to go get lunch. But yeah, just shoot me a message and I'll answer what I can, okay?
All right. Thank you.
No problem. I'm going to go ahead and leave, okay?
All right, bye.
Bye.